Hey everyone, in this video we're going to be going through some passages and then answering the questions related to them. And I scored in the 99th percentile on the MCAT, so with this video I'm trying to show you how I would look at a passage, look at what information matters and what doesn't, and how I would break down the passage, and then how I approach all the questions, how I see what the question is asking me, and then go through all the answer options, see what's correct, what's incorrect, eliminate them one by one until I have the final correct answer. So hopefully me going through these passages will show you a right approach or like the approach that I used, and if you apply these techniques that should help you increase your score as well. Of course, if you have any additional questions, leave them in the comments below, but as I go through all these questions I won't assume that you know too much background knowledge. Like, of course, I'll assume you have done some studying for the MCAT, but all the information that you need for a question, what is present in the passage, I'll try to show you where it is and how you can use that information to answer the questions. So without any further delay, let's get through the passages. So the passage tells us that several features of sulfuric acid are given below. First, they talk about the preparation of this acid. Sulfuric acid is commonly prepared by the combustion, sorry, some of this is cut off, that says combustion of the element sulfur to sulfur dioxide. So essentially what they're saying is sulfur is going to react with oxygen to give us sulfur dioxide. Then that is followed by the catalytic oxidation of sulfur dioxide to sulfur trioxide. So now we have sulfur dioxide reacting with, let's say, two of these with oxygen to give us 2 sulfur trioxide. So just keep in mind what reactions are taking place. Just step by step break it down in your head and make sure you actually understand what's going on. So element sulfur went to sulfur dioxide, then that was oxidized again to sulfur trioxide, and then now sulfur trioxide is absorbed into a 98% aqueous solution of sulfuric acid. That's H2SO4. Water is added to maintain a 98% concentration. The SO3 is going to react with water in the aqueous solution according to reaction 1. So that would be this thing over here. So just look at what's inside the box. The sulfur trioxide, which was formed now, is reacting with water to give us sulfuric acid. So we have a 98% concentration of sulfuric acid. 98% is the acid, 2% is water. Next we talk about some properties of concentrated sulfuric acid. So like I just said, 98% is the acid, 2% is water. This is by mass. Okay, keep that in mind, that it ends up being useful when we're talking about calculations for a question later on. But yeah, here it says by mass. That's something that should pop out to you. And then whenever they have any numbers like this, like saying like the density is this much, just keep that in mind. You don't have to, like, you know, commit it to memory or, like, you know, remember it a little bit, and like you don't have to worry about any of that, the numbers itself. Just know where in the passage they are. Okay, density is mentioned over here, boiling point is mentioned also over here. So there's this one paragraph that gives us all these properties. Maybe they come into use later on in some of the questions, maybe they don't. Just know where they are in the passage. The next thing which is discussed is preparation of other acids. So sulfuric acid can be used to prepare other acids like hydrogen chloride, or like HCl or HNO3. These may be prepared by the reaction between sulfuric acid and a sodium salt of the corresponding conjugate base. So if we had, for example, H2SO4 and then we reacted it with NaCl, they're saying that that is going to give us, as one of the products, HCl. So this isn't a complete reaction equation, but they're just saying that reacting it with something like this is going to give us HCl. If we had NaNO3, we get HNO3. So that's what they're telling us here. Next, we talk about the formation of SO2. Sulfuric acid, it can form SO2 gas when it reacts with several compounds. For example, iodine and sulfur dioxide, these are formed when the iodide anion, when that reacts with concentrated H2SO4. So here they're saying, what's the reaction? Let's just, you know, kind of understand what's going on. You can do this on the piece of paper you get with the MCAT or just in your head. When these two things react, we get iodine gas and then SO2, and then you can imagine similar things happen with other halogens. we get bromine gas when bromide reacts, and so on. And then in this case, what is over here is copper with a plus charge. This cation is formed along with sulfur dioxide when we have hot solutions of copper metal reacting inside H2SO4. This last reaction is unusual because most metals, they react with solutions of sulfuric acid to give us hydrogen gas and a metal sulfate. And that's it for the passage. So now we can get into the questions. So a lot of information on different types of things that can happen with sulfuric acid. We may need some of it, we may not, but thankfully this passage, it organized them into nice paragraphs where we can always find the type of information that we need. So question 59 is saying, when sulfuric acid reacts with copper, how does the oxidation number of the sulfur change? So what was the reaction? We had H2SO4 was reacting with copper, and that gave us this cation plus SO2. That was discussed right here at the end, this final passage, or this final paragraph in the passage. And what happened is the sulfur went from H2SO4 to SO2. So we care about the oxidation number of the sulfur. So oxidation number for hydrogen, it's always going to be a +1 in these kind of compounds, and for oxygen it's going to be a -2. So those are common oxidation numbers you should have in mind. And then since we have two hydrogens, actually we have a +2 charge that's contributed overall to the entire charge of the compound, or the oxidation number of the compound, by hydrogen. And then there are 4 oxygens, so 2 times 4 is going to be -8, and overall you don't see any charge, right? So that means that it has to balance out, it all has to be neutral. We have +2 -8, that means there's a -6 charge right now, so +6 has to be what the sulfur has as its oxidation number. So +6 is on this sulfur. So it used to be +6, and then this oxidation, or this redox reaction, took place, and then we see what happens to the sulfur afterwards. The oxygen still has a -2, but there are 2 of them, so that means that overall there's a -4, and since the compound is neutral, sulfur has to balance that entirely, and so it has to be +4, so +4 -4, they cancel out to give us 0. So in this case, what happened, let's make it a different color, make it like orange or something. Sulfur was +6, now it's +4. So it went from +6 to +4. So that means that B is going to be our correct answer. Moving on. Okay, this question over here with this apparatus. Question 60. This apparatus shown below can be used to prepare HNO3. The boiling point of that is 86 degrees. Okay. The yield of HNO3 collected in the tube can be maximized by maintaining the temperatures of the flask and tube respectively at what temperatures? So I'll just erase this because it's kind of in the way. This is a flask right here. This is a tube. So we have the sulfuric acid up here, and NaNO3, that's sodium salt, down here. The sulfuric acid is going to come into the solution. We're going to form HNO3 gas, and then if we heat up the solution down here at the bottom, that gas is going to then eventually go up here. And then if this tube over here is cool enough, then we're going to get condensation, and then we're going to get a collection of HNO3 in the tube. But that can only happen if this flask is very hot enough that it's higher than the boiling point of HNO3, and then that becomes a gas, and then the tube has to be cool enough that that gas then condenses. So we were told at the boiling point in the question, we were told it was 86 degrees Celsius. So the question is asking us the temperatures of the flask and the tube respectively. So the flask should be something greater than 86, so it can't be option A. Option B makes sense. If it was 100 degrees Celsius, then yes, the HNO3 would evaporate. That's higher than 86. And then if the tube was 0 degrees Celsius, that's below 86. So that's going to lead to, yes, a nice amount of condensation, and that's going to maximize how much of the gas or the compound HNO3 as a liquid we eventually collect. So B makes sense. in C and D, if you heated it up that high, yes, you would get the compound to evaporate, but then it wouldn't condense. If it's 150 degrees in the tube, it's not going to condense because that's higher than the boiling point. Same thing over here with D. So because of that, we can remove options C and D, and B is the only choice, which makes sense. Question 61. This question is asking us which of the following is a balanced equation describing the combustion of elemental sulfur. So, combustion of elemental sulfur. So just going back here to the passage, where were we told that the preparation of sulfuric acid, we're told that we have the combustion of elemental sulfur to sulfur dioxide. So we're going to go from sulfur as the element, which means we just have like an S, and then combustion is when we have a very exothermic reaction taking place. So it takes place like at high temperatures, and we react something with oxygen, and we were told that that gives us sulfur dioxide. That's what the passage told us. So this is the reaction that we're looking for. You're reacting with oxygen, your product is going to be sulfur dioxide, and we're looking at elemental sulfur. So like option 1, you can see the oxygen here, or option A, you see the oxygen, you see the sulfur dioxide, but then like why do we have H2S over here? Why do we have hydrogen sulfide? We're told we're reacting, or we're combusting the element sulfur. So you just need to write S. It's not hydrogen sulfide. B is also incorrect. It's not hydrogen sulfide. And why is there SO3 instead of SO2? So that's incorrect. Option 2 somehow, or option C, sorry, for some reason it has SO3 as the reactant. And like this is going backwards. And also why is it SO3 instead of SO2? So for multiple reasons, option C is incorrect, and our correct answer is option D. Just the element sulfur, combustion reaction. When you learned all the different types of reactions, you should know combustion is reacting with oxygen, and then the passage told us that it becomes sulfur dioxide. So option D is the correct answer here. And question 62, I'll just erase this other stuff. It says in the second step of preparing sulfuric acid from elemental sulfur, which is a catalytic oxidation of sulfur dioxide, which strategy is most likely to increase the yield of SO3 formed? So in that case, we had sulfur dioxide, and then it was being oxidized, and that gave us SO3. So to balance it, we put these 2's over there as a coefficient. Keep in mind that everything here is a gas. Okay, so in this case, what we want to do is increase the yield of SO3. That is our product. What are some ways we can increase the yield? Well, whenever the MCAT asks you these type of questions, it's usually something to do with Le Chatelier's principle, which is just saying that if you have an equilibrium and you disturb it somehow, then the system is going to respond to the stress by readjusting as much as it can to reestablish an equilibrium. So that means that like if I have a lot of reactants and I have no products present, then what's going to happen is a lot of the product is going to be formed. And then some ways that I can increase the amount of product that I have is if I was to decrease the amount of SO3, I start taking this away, that would once again leave me with a lot of reactants and not much product. So we're going to have more of the reactants reacting to form more of the product. And then also because these are gases, when you increase the pressure of a system where you have gases, then you're going to have the equilibrium shifting to the side with fewer moles. Because if you just imagine you have an increased pressure in the system, a lot of things are bouncing around. That's, you can think of that as like stressful situation. You can have less stress if there are fewer particles moving around, meaning fewer moles. So I guess this would be an equilibrium then. And now let's look at the answer options. Option A is saying reducing the reaction temperature. Would this increase the yield of the product? No, it wouldn't. Every reaction has an activation energy barrier that you're trying to get over, and adding more temperature is going to increase the likelihood that the reactants have this activation energy, and then they can react and form the product. So increasing temperature would increase the amount of product we get, but reducing the temperature wouldn't. So the reducing part is incorrect. Option B is saying reducing the reaction pressure. Here the reducing part is incorrect again. So like I said, increasing the pressure is going to shift to the side with fewer moles. You see that there are, like there's a 2 here, and then there's a 1 over here. So there are 3 on the reactant side, and then there are 2 moles on the product side. So increasing the pressure would shift towards more products, but reducing the pressure would do the opposite. It would shift towards the side with more moles. So it's going to shift towards the reactant side. That's the opposite of what we want. Option C is correct. Just if we start removing the SO3 from the reaction mixture, there's less of the product, and then this system is going to react more to create more product. So that's how we can increase the yield of SO3. D is incorrect. If we started removing oxygen from the reaction mixture, it'll go the other way, and then we'll get less product, and we'll get more of the reactants forming and more oxygen. So if you had less oxygen, right, just think about it, it doesn't make sense. You're trying to react the SO2 with oxygen, and if you just have less of it, then you're going to get less SO3. So removing oxygen doesn't really make sense. So C is the correct answer here. And what else we got? We still have a few more questions. Question 63. Which of the following expressions can be used to determine the number of moles of water in 1 milliliter of concentrated H2SO4? Okay, we want to know moles of water. We have 1 mil of that concentrated sulfuric acid. Okay, so keep that in mind. We're looking at moles of water. For that, we come over here to this part with properties, and when we're talking about concentrated sulfuric acid. So this told us that 2% of this solution is water by mass. So keep that in mind. This is by mass. But we were told that we have 1 milliliter of the sulfuric acid. So that means that we have to turn the milliliters into mass first, or into grams, and then we can move forward with the calculations. The next sentence just tells us how to do that. It says that the density of the sulfuric acid is 1.84 grams per milliliter, and then that's pretty much all we need to know. So those are the numbers. So if I have 1 milliliter and I multiply it by 1.86, sorry, it was 1.84 grams per milliliter. The milliliters are going to cancel out. So how much water do I have? Or sorry, how much of the actual sulfuric acid do I have? I have 1.84 grams. 2% of this is going to be water. So if I take this number and I multiply by 2%, which is just 0.02, what is that telling me? That's telling me how many grams of water. And this is equal to grams of water. But the question is asking us for moles of water. So moles is just mass over molar mass. So if I just like take this thing, plug it in here for my mass of water, and then I divide by the molar mass of water, which is just 18 grams per mole. That you should know. Like if you do practice with like mole calculations, you come across water all the time. Molar mass of water, H is 1, so we have 2 H's, so that's 2 plus oxygen is 16, so that's why it's 18. And then if you just do that calculation, whatever your answer is, that is the number of moles that we have for water. But if you look at all the answer options, they're not actually asking you to find that. They're just saying do some dimensional analysis and figure out how to set up the calculation if you want to find out moles of water. So you don't need an actual number. So in this case, once again, we took 1 and we multiplied it by 1.84. That gave us mass of the water. Mass of the sulfuric acid. We had to figure out how much of that was water, and 2% of that was water, so we had to multiply by this. And then that's mass. We want moles, so we divide by molar mass, and this is how we do it. This is our setup. And if you just ignore the 1, that best matches up with option B. All the other ones are incorrect. I don't know why option A has like addition of two things. That's incorrect. Option C is incorrect because this is looking at sulfuric acid, which makes up 98%. Water just makes up 2%. And then for D, it's all over the place. I don't know why like 18 is up here instead of in the bottom. I don't know why 98 is in the bottom and 0.98 is over here. Yeah, that one's all over the place. So B is the correct answer, and this is how we set up the answer. Moving on to question 64. It says if hydrogen gas is formed from the reaction of iron with dilute sulfuric acid, which species acts as a reducing agent? So what did the passage tell us? Last sentence right here, it says this last reaction is unusual because most metals, they react with solutions of the sulfuric acid to form hydrogen gas and a metal sulfate. So we have H2SO4 reacting with the iron, and then that gives us hydrogen gas and some type of iron sulfate, like I guess we say like FeSO4. Which species is acting as the reducing agent? If you just look at iron, first of all, it was in its elemental form, so its oxidation number, it would have been 0, and now it's changed. And SO2, like when you have H2SO4 and that like completely dissociates, what do you get? You get 2H plus and SO4 2 minus. This whole thing can be like a 2 minus. So that means the iron has a positive charge. So it's like plus 2. That means that the iron was oxidized. And whatever is oxidized itself, that's going to be the reducing agent, right? That's what they're asking us here. What is a reducing agent? That's the thing that reduces something else and it itself is oxidized. So it's going to be iron. Another way of looking at that is just look at what's happening with the hydrogen, because we're told that hydrogen gas is being formed. So in the H2SO4, we did this in a previous question, but for hydrogen, its oxidation number is going to be +1 for each individual oxygen. Overall, it's going to contribute +2 to the overall compound. And then over here, now on the right, it's in its elemental form, so it's 0. So it went from +1 to 0, which means it gained electrons. And then you should know from oil rig, oxidation is loss of electrons, reduction is gain of electrons. Okay, so I'll just write that right here. Oil rig. Reduction is gain of electrons. It was plus charge. If your charge went down, you gained a negative species as electrons. So hydrogen was reduced. The reducing agent must be the other compound, and the only other reactant here is the iron. So it's the iron which is the reducing agent. I guess the whole point of this question is like maybe you don't often think of metals as being reducing agents like that. Like it's a pretty interesting reaction, right? Like I guess you see metals being reducing agents when you are reacting them with other metals, but we don't often see a reaction between metals and acids like that. Either way, this is just a redox reaction, just asking you what's the reducing agent. Sometimes people get confused between, you know, are you being reduced if you're the reducing agent? No, it reduces the other thing, and it itself is oxidized. So iron is the correct answer here. It's not the iron sulfate, that's one of the products. It's not this thing either. It's not, I don't see any reason why it would be C or D. It's going to be either the iron or the H2SO4, and in this case it was the iron. And that leads us to the last question. Question 65. Which of the following species has the smallest concentration in 98% H2SO4? So for an acid like this, and hopefully you've already come across H2SO4 before, for its first ionization, it's like a decently strong acid. It'll give us, let's say it reacts in water, okay, plus water, it'll give us H3O plus and then HSO4 minus. That's the first reaction, and then that can go forward. You can have HSO4 minus, that reacting with water again. This is a diprotic acid, and you get another H3O plus SO4 2 minus. If we had more water, these reactions would take place more often, and you'd get more of the acid acting as an acid and giving away its proton, forming the hydronium ions. But in this case, 98%, it's very concentrated acid. There's not that much water, so there isn't that much of this reaction going forward. And additionally, for multiprotic acids, the first time you're deprotonated, that, like, depending on the acid, it is whatever pK it is, right? For H2SO4, it's a decently strong acid. It'll lose that acid, it'll lose that proton, like, kind of easily. But afterwards, subsequent deprotonations are always higher in pK. So you'd have to have at least some base present. It should be a more basic solution before you get that second proton ripped away. Because having that one negative charge, okay, that's fine. But creating like a species with 2 times a charge, whether it's positive or negative, that's hard to do unless you have something making that happen. And if it was a more basic solution, that would happen. So the pKa for this one, it's like, we could say it's all right. It's kind of like small, but then the pKa over here is just too high with this few water present, just 2% by mass. So we're not going to get a lot of this compound, is what I'm trying to say. The likelihood that we're going to get a lot of this, not high. So this is a thing which would have the smallest concentration. Of course, if it's 98% sulfuric acid, we're going to have a lot of sulfuric acid. It's not unreasonable that that's going to react with a little bit of water present there, and water also, it automatically like self-deionizes, or it ionizes by itself. That also doesn't happen to too great an extent, but the presence of H2SO4 is going to lead to more hydronium ions. We can also expect that we have, at least somewhat of HSO4 minus, but compared between like A and D, you're definitely going to have much less of SO4 2 minus. So because of that, A is the correct answer here. That's it for the questions in this passage. If you look down in the description, you will see that we have a course, right? We have a 30-day MCAT course. All the information for that is down below. You can check out our website. We also have like a webinar that plays from time to time, and it can give you more details on what is in the course. But essentially, what you saw here is what is going to be present in the course. We have lecture videos going through all the different topics that are covered on the MCAT and explaining those topics to you, but like at the level that you need to know for the MCAT. We don't try to go like way too beyond, because you don't have to for the MCAT. And then a lot of videos for like over 1,000 questions, going through the questions, going through the answers, breaking it down like you saw here, and then trying to teach you this method of approaching questions critically as well. So if you like what you saw, make sure to check out the link and see if this course is right for you. We call it 30-day MCAT course. You don't have to only be willing to study for 30 days to take this course. We have schedules for 30 days, but also for 60 days, for 90 days, or just however long you need to study. So you can just get in the course, you can move along at your own pace. The main thing is, if you like what you saw in this video, then check out our course. And that is it for this video. I'm going to end it off here. If you have any more questions, reach out to us, social media, email, everything like that. So thanks for watching. See you guys in the next.